All right, so this would be the fourth lesson we've done. We'll talk about absolute value equations today. All right, so the first question that we got to answer is, what is absolute value? We know what it does, but what is it? It's a distance the number is from zero. Okay, so that is exactly the right answer. So the distance from zero. Okay, and now first example, absolute value of x is equal to 7. The easiest absolute value equation I can give you. What numbers have a distance away from zero of 7? 7 and negative 7. Absolutely that. So there are two equations that are set up here. One of them is x equals 7. The other one is x equals negative 7. Since there's nothing to do with the x, there's no operation happening with that x, then you're done. You don't have to do anything else. Those are the two answers. What the idea here is that as you go into these, you're going to get more stuff inside of the absolute value, and you've got to do the solving for that. You've done some absolute value equations before, but just want to review all of those techniques that are needed. So let's look at this one. Absolute value of x is equal to negative 4. Maybe I lied to you. Maybe the first one wasn't the easiest one. Maybe this one was. What about that? What do we know about absolute value answers to absolute value questions? Yeah, distance is always positive. If you have a tape measure here, and you go to Lowe's or the hardware store up here in town, or Walmart or anywhere, they sell a tape measure. I will give you $100 for it if you can find one that in the store has negative numbers on it. They don't make them. Distance is never negative. So absolute value can never be equal to a negative number. So anytime you get the absolute value isolated and it's equal to a negative, and you know that that is no solution. Because distance can never be negative. Distance is always positive. There used to be a movie y'all probably have never seen, Ferris Bueller's Day Off. Anybody ever seen that? You know, where he drives his dad's sports car around. Skips school one day. He drives his dad's sports car around, runs up tons of miles on it, and his dad's real particular about his car, and he knows how many miles it had on it. So he tries to roll it back by putting the car up on jacks and putting it in reverse and running the odometer back. That doesn't work. He just keeps clicking more miles because distance is positive, and the odometer, as long as the wheels are turning, it's counting positive distance even when you're going in reverse. So it doesn't work that way. So, all right, now let's get into some that actually got to do some work with. All right, so let's start with absolute value of x minus 9 is equal to 5. Okay, so with this one, you have an absolute value, which is the distance away from 0, is equal to 5. So what two numbers have a distance away from 0 of 5? Negative 5 and positive 5. So what you have to do is you take the stuff that's inside of the absolute value marks, you're setting it equal to positive 5 and negative 5. You have to set up two equations. Don't solve first. Get the absolute value by itself and then set up two equations and solve each one of them separately. So you add 9, that'd be 14 for the first answer, and that would be positive 4. So two different answers, both, if you plug them in, work. 14 minus 9 is 5. The absolute value of 5, 5. 4 minus 9 is negative 5. What's the absolute value of negative 5? 5, just like the answer is positive 5. Absolute value always gives you a positive result. Okay. There beside that, let's flip it around here. 3 equals absolute value of 2x plus 7. Does that change how that problem's done? Going to still set up 2 different equations. One of them is going to be 2x plus 7. Nope. What's the absolute value equal to? It's equal to 3. So we need the absolute value stuff equal to positive 3 and negative 3. And then solve those. So this one a little bit more work because it's got 2 steps in it, but not a terribly difficult problem. Divide by 2. First one, I got negative 2 as an answer. The second one, subtract 7. 2x is negative 10. Divide by 2. And I got negative 5 as a solution. So the absolute value, notice on every one of them we've done so far, all 4 of them, that the absolute value was by itself first. And then we had it equal to a positive number. If it's not equal to a positive number, it's equal to something negative, then you know it's no solution. You don't even have to work it. But you get that absolute value isolated or by itself first.
Carly Tate, report to class.
All right. And then set up 2 equations and solve them. That's the idea here. So let's look at example 5. Absolute value of y minus 1 plus 17 is equal to 23. Is the absolute value isolated on this problem? No. So we need to isolate the absolute value part. So what do we need to do first? Yeah, move this 17 out of the way. So we subtract that, and there's our absolute value by itself now. 23 minus 17 would be 6. And now we have an absolute value that's equal to 6. So what are our 2 equations that we set up to solve? Yeah, I said 6 and I wrote it. Y minus 1 equals positive 6, and y minus 1 equals negative 6. I keep saying it. Say the 6 and write it. It doesn't matter what order you do that in. If you put the negative one on the first one and then the positive one, it doesn't matter. Just getting 2 answers here. So add 1 real easy here. Y is 7. Add 1. Y is negative 5. We get our solutions to that problem. So again, isolating the absolute value, look at what it's equal to. If it's equal to a negative, you don't even have to work it. It's no solution. If it's equal to a positive, you got to set up 2 equations. Example 6, 3, absolute value, x plus 8 equals 39. Close, but not right. Why do we need to divide by that 3 instead of distributing it? I need to isolate the absolute value. That's the main reason there. But here's the reason that we want to just get rid of that 3 by division instead of distributing it. Because our instincts say if we see grouping symbols and a number outside, distributed property is usually what we do. But because that grouping symbol here is an absolute value mark, we don't want to distribute because we don't know if that 3 was a positive 3 to begin with or if it was a negative 3 to begin with. Because, you know, if it came outside of the absolute value, it could have been either one, and we don't know which one it was, but we just know that right now it's a 3 out there, and I can get rid of it by division, and I don't have to worry about which one it was. So if I divide by 3, that gets rid of that. That'll be 13. And can that be solved? Yeah. So we set up 2 equations. X plus 8 equals 13. X plus 8 equals negative 13. That'd be 5 and negative 21. By subtracting, I didn't show my step of subtracting 8 there, but we all know that's what we were doing to get there. Y'all remember doing this in Algebra 1? Probably didn't do much of this in geometry at all, but you did a little bit of this in Algebra 1. If you had year-long Algebra 1, it was in the fall of your freshman year, which was a while ago for most of us. So it's maybe been a while since you've done this. So that's one of the reasons that we go over it again, just to get your kind of try to find those brain cells that stored that information somewhere in there. 16, absolute value of x minus 5, close the absolute values, plus 2 is equal to negative 30. Okay, hold on. I heard two different things there. So he said subtract 2. Not a bad idea. What was the other thing I heard? That's what you said too. Okay, all right. Yeah, great idea. Because we want to do what? Get that absolute value stuff by itself. So getting rid of that 2 is a good idea. Even though at this step, we got it equal to a negative, we can't decide until the absolute value is isolated whether or not it's no solution. We got to get that absolute value isolated first. So 16 absolute value of x minus 5 is equal to negative 32. All right, again, divide by that 16. Good job. And that is going to get an absolute value equal to negative 2. Now we can decide that that's no solution. Cannot decide whether it's no solution until you look at it with the absolute value isolated. Just make sure that that's what you're looking at to decide if it's no solution or not. Okay. Let's look at a kind of a weird looking one. Absolute value of x minus 10, big fraction bar, over negative 2 is equal to negative 6. Which would be by multiplied by negative 2. So undo that big division that's happening there. Want to divide, or they're dividing by negative 2. We're going to multiply by negative 2. Those cancel each other out. And there's absolute value of x minus 10. And now it's equal to what? Positive 12. Which, does that have a solution? Or solutions? Yes. So we set up our two equations, which are what? Yeah, getting kind of boring at this point, isn't it? So this will be 22. This will be negative 2. Okay. So you see that big fraction thing, just to undo that is going to be a multiplication. That's all you've got to do out of that. All right.
Madison Harris, report to class.
All right. Let's look at some that are getting a little bit more complicated, maybe a little bit more Algebra 2 level, or some that have some common mistakes that I always see when we're going through class over the last 100 years I've been teaching. All right. So you might tell me what the first step to this problem would be. All right, I heard three different things. I heard divide by negative 4, but the absolute value part with the negative 4 on the front is not by itself yet, so we can't do that. Subtracting 9 would work. Why can't I say 9 minus 4? Very good. The negative 4 is multiplying times that absolute value stuff. So order of operations says, hey, you can't do that until you get, you've got to get all multiplication and division done. If you're going to simplify a side, you've got to follow order of operations. So order of operations says you can't subtract 9 minus 4. That's the most common mistake that I see with this problem. There's be careful of that. So subtracting 9 is the right step. And there we get the negative 4, absolute value of x plus 10 equals negative 24. And now we can divide by that negative 4, which works out a little cleaner. Positive 6, which can that be solved? Yeah. Negative 4, negative 16. There are two solutions to that. And if it's an equation, guys. So if you get answers, you can take them and put them back into the original problem and check each side to make sure they equal the same thing. No sense in not knowing if you got it right or not, or if the the answer you're submitting is correct. All right. Number 10. Let's look at this one. Negative 16 equals negative 12. Absolute value of x over 5 plus 8. So throw in a fraction looking thing in there because everybody loves those. Subtracting that 8 would be a great idea. Get that absolute value by itself. That's going to be negative 24. Negative 12, absolute value of x over 5. Dividing by the negative 12 would be a good next step. Good job. All right. X. Can that be solved? Yeah, because it's equal to a positive. That means we can set up our two equations. X plus 5 equals positive 2. X over 5 equals negative 2. How do you solve those? Yeah, times 5. What you do on all of that. So x is equal to 10 and negative 10. One of the rare occurrences when you get the same number but one positive and one negative on your answers. Most of the time with your practice that you're going to get today, you won't get the same number with opposite signs. You'll get something different. In case in point, all our other examples that we've done. All right, let's do a hard one. Number 11. Absolute value of 3x minus 9 equals x plus 1. Not necessarily, no, because it's an absolute value equation here. If the absolute value wasn't there, then yes. But the absolute value being there tells us we've got to isolate the absolute value part first. Is the absolute value by itself on one side? Yes. Then that means that we can set this up to solve as an absolute value problem. We don't know what x is on the other side, but we know that our answers have to be positive when we get done, right? Or the answer to the absolute values have to be positive. So we're going to set up two equations. 3x minus 9 equals the positive side of x plus 1, which is just leave it the same. And then the other equation is going to be the opposite of that, which would be negative, and then x plus 1 in parentheses like that. So that changes the sign of the other side. Okay, let's do the left-handed one here first, the easy one there. So subtract the x and add the 9, and we get 2x is equal to 10, and x is equal to 5. So that's where the 5 comes from. Now, what should be the first step on the right-handed one? Yeah, this one we do distribute the negative to both of those things to get negative x minus 1. And then I would add x. It'd be 4x, and I would add 9 over here. Equals 8. So x is going to be 2. Now, we haven't been going back and checking all of our answers, on every problem. When you have problems where you have variables on both sides, especially with absolute values, that's when you really have to go back and check. So what we want to do is check those answers and ensure that they do work in this problem, because it's possible that we end up with a negative on the other side, on this x plus 1 side, and you can't have an absolute value that's equal to a negative. So I'll plug a 5 in to each side. So the left side will be 15 minus 9, which is 6. The absolute value of 6 is 6. On the right-hand side, 5 plus 1 is 6. So that's that works. Let's plug the 2 in and see if it works. 6 minus 9 is negative 3. The absolute value of negative 3 is positive 3. On the other side, what's 2 plus 1? 3. Does that check? Yes, both of these work. It is possible that you get two answers and you check them and only one of them works. And you have what's called an extraneous solution, which means it's an extra answer that doesn't work in the problem. So especially when you have variables on both sides, you need to check your answers, especially today. Okay, so make sure you're going back and checking those. Let's look at a couple more of those that are kind of like that. Let's try 2 absolute value of x plus 8 is equal to 14x. All right, so idea here is to isolate the absolute value. So we get rid of this 2 first. No matter what's going on, we got to get that absolute value by itself. So 14x divided by 2. 7x, good. Set up 2 equations. 7x, x plus 8, and negative 7x. Yeah, that's the other one. So solve those 2 problems. So subtract x, and 8 equals 6x, and divide by 6. And that doesn't go evenly. So I'm going to have a fraction as an answer, but I need to reduce it as far as it will. So what does 8 over 6 reduce to be? Yeah, 4 over 3. And if you're using the calculator to do that and you did 8 divided by 6 and hit enter, it gives you the decimal back. How do you change it back to a fraction? Math, enter, enter. Yeah, that's the trick to get it to do that. If you use the fraction button, alpha y equals, and do 8 over 6 and hit enter, it will reduce it for you as you go there. So using the calculator to help you reduce some fractions. So 4/3 is a possible answer. And then let's find the other one. Subtract x. 8 is equal to negative 8x. Divide by negative 8. That's negative 1. Now, I need to check these. So I plug in 4 over 3. And 4 over 3, we're checking to make sure this is right. 4 over 3 plus 8. I can do that with my calculator. 4 over 3 plus 8. Enter. And then math, enter, enter. And then multiply that. The absolute value of that would just be 28 over 3 times 2. Because that's what the left side of the original problem had. 56 over 3 is 14 times 4 over 3. 4 divided by 3. Math, enter, enter. Yeah, it's the same number. So 4 over 3 works. We checked it. It's staying. What happens when I plug in the negative 1? I get negative 1 plus 8 is 7. And we can take the absolute value of 7. It's 7. 2 times 7 is positive 14. On the right-hand side, what's 14 times negative 1? Negative 14. Does 14 equal negative 14? No, they're way apart on the number line. They're 28 units apart. They're not the same number, okay? So that one, we found that answer by doing our work, but it doesn't work in the original problem. So that's what's called an extraneous solution. The way that I like for you to show that, you did all this work, don't throw it away. Just put an X like that through that answer. It shows, hey, I found this answer, but it doesn't work. So put me an X through that. And that way, if for some reason you maybe make a sign mistake when you're checking it and you happen to throw away the wrong one, I can still give you some partial credit on the quiz for getting the right answers. And then you just accidentally threw away the wrong one. So make sure you can still see that answer. Just put an X through it like that. That works out pretty good to get us our solutions there. All right. Let's finish up with a really tough one. Last one of the day. Absolute value of 8 minus 2n, close the absolute values, minus 5n is equal to n plus 2. A lot of stuff going on with this. Okay, so how do we do that? Okay, adding 5 in would be a good start. So I'm going to put that with the like term on the other side. All right. All right, set up the equation. So we got 8 minus 2n is equal to 6n plus 2. 8 minus 2n. 8 minus 2n is equal to what? Yeah, negative 6n minus 2. If you want to go ahead and just distribute the minus sign to all of those, just change the sign of everybody on that right-hand side. Everybody's sign changes. Okay? And then we're just going to solve these two. So I'm going to add 2n and subtract 2. 6 is equal to 8n, which is almost the same thing we got a while ago. Yeah, it says 3 over 4 instead. Let's write the right number down. How about 8? And then 6 over 8 reduces to 3/4. So we get a fraction answer, and that's okay. That happens. And then we're adding 2n. And then I'm going to go ahead and add 2 at the same time. So 10 is equal to negative 4n. Divide by negative 4. Negative 5 over 2. Yeah. Okay, so I got 2 fractions on that. But I just need to check them to make sure that they work in the original. And the original is a little bit more complicated because it has absolute value and some stuff that's not absolute value on the left-hand side. So we got to be careful about that. So 3/4, if I plug that in, here's the shortcut to this. Is 3/4 plus 2 going to be a negative? No, it's not, right? Is negative 5 over 2 plus 2 going to be negative? What is negative 5 over 2? It's negative 2.5, isn't it? Negative 2.5 plus 2 is a negative 1/2. Now, that makes me think this may not work. I'm going to go over to the left-hand side and plug it in over there and see if it works. 8 minus 2 times negative 5 over 2 in the absolute value minus 5 times negative 5 over 2. All right, so that's going to be 8 plus 5 there inside of there. So that's 13. And that's going to be 25 over 2. 13 plus 25 over 2 would be, yeah, put that over 1, multiply by 2. So 26 over 2 plus 25, 51 over 2. That's what the left-hand side equals. Does the right-hand side equal that? No, the right-hand side was equal to negative 5 over 2. What was the original problem? Plus 2, which was negative 1/2. Does 51 over 2 equal negative 1/2? No, that doesn't equal. So guess what? We're throwing that one out. Found 2 of them. Only one of them works. Again, you got to check them to make sure you're getting the right one. Now, you're not always going to throw out the negative one, even though that one happens to get thrown out a lot, but not all the time. Sometimes you may end up keeping the negative one and throwing out a positive one. Don't go by the sign of the answer. Go by what you're plugging in and checking. It's got to work in the problem for it to be a solution out of that. So it's going to take some practice with those. Again, most of the ones you're going to see don't have variables on each side. But some, you get down to toward the bottom of this, the last 4 problems do. So there's 16 problems. 12 of them are pretty normal, and only 4 of them that are kind of funky. So